Hey, great job on 7-1, everybody. We're going to get after it in 7-2 today. So more of the same. We're going to learn a word today we haven't seen before. It's called the converse. Converse. No, we're not talking about shoes. All right? Anyway, here we are. 7-2, take it away.
How can you determine whether a triangle is a right triangle? Think about this question during the lesson. Triangle ABC has side lengths A, B, and C.
This looks familiar.
So that A squared plus B squared equals C squared.
We're now a little bit better at this.
Construct a logical argument to show that triangle ABC is a right triangle.
Okay.
You have to show that angle B is a right angle to prove that triangle ABC is a right triangle. Let's draw a right triangle DEF.
Yep.
With leg lengths A and B and hypotenuse length X.
Not C? I thought, look, we were all thinking they were going to call it C.
Since triangle DEF is a right triangle, by the Pythagorean theorem, we know A squared plus B squared equals X squared.
Yep.
We can use substitution to show that C equals X.
Yep.
We are given that A squared plus B squared equals C squared. And we know that A squared plus B squared equals X squared.
Mm-hmm.
By substitution, C squared must equal X squared.
That makes sense.
If we take the square roots of both sides,
C is equal to X.
It also must be true that C equals X.
Absolutely.
Is triangle DEF congruent to triangle ABC?
Select your answer.
What do you guys want me to pick? Do you want me to pick no? Do you want me to pick yes? Who said no? Come on. Absolutely they're congruent. Come on, people. We just wanted to hear this sound anyway.
The three sides of triangle DEF are congruent to the three sides of triangle ABC. So there is a sequence of transformations that maps triangle DEF to triangle ABC. The triangles are congruent. Therefore, angle E must be congruent to angle B. Angle B is a right angle, so triangle ABC is a right triangle.
Yep.
This is a proof of the converse of the Pythagorean theorem. If A squared plus B squared equals C squared, then triangle ABC is a right triangle.
Yep, and guys, that's what we're after today. So they're going to give us side lengths, and we are going to figure out, is this a right triangle or is this not a right triangle, right? And it's literally just more work like we did the other day of plugging in A, B, and C, where they go into that formula, okay? And then figuring out, hey, do these two numbers equal this number we have over here? Mr. Knowles taking my calculator. Can you believe he would do such a thing, people?
My bad.
Yeah, I can. Although I probably don't need to know this one. All right. Triangle has side lengths of 4, 5, and 7. So again, identify the longest side. That is your hypotenuse. That is your C value, okay? Does not matter where A and B go. They're both 4 and 5. So 4 squared plus 5 squared equals 7 squared. Again, we're figuring out, is this a right triangle, okay? So 16, 25, 49, okay? So then it says, is A squared plus B squared equal to C squared? Well, guys, what is 16 plus 45? Anybody know? Nobody? Well, that's 41. Is 41 equal to 49? Like, are those equal to each other? So, no. Is A squared plus B squared equal to C squared? No. Is this triangle a right triangle? No. Absolutely not. Okay? Absolutely not. That's all we're doing today, folks. That's it. We call this the converse of the Pythagorean theorem. Okay? We're proving if a triangle is a right triangle. Seems fun enough, I suppose. Let's see what else they can do. Okay?
Part A. Is triangle XYZ a right triangle?
Okay? Again, they've labeled the triangle for us. Legs of 7 and 24, hypotenuse of 25. Okay? So all we have to do is figure out, hey, if we're going to plug these in, look, we're going to go 7 squared plus 24 squared does that indeed equal 25 squared? Right? I don't know. Maybe it will. Okay? We're waiting for the tumble machine to load. Okay? What happens, guys? So again, just look, this is where we left off. They went ahead, squared both numbers, add them together, they get 625. They squared 25. Yes, indeed, they got 625. So because those numbers are equal to each other, our triangle is indeed a right triangle. Okay, that was fun. Let's see what else we got here. Part B, the side lengths of a triangle are this. 6, 4.5, and 3.75. So we're getting into bad numbers here. The process is still the same. Okay? 6, 4.5, 3.75. Is this triangle a right triangle? Well, again, A and B, your two legs are right here and here. Okay? 6 is going to be your hypotenuse. So we have to plug all of those in. All right? Again, make sure you're doing this in the right order. This is the only way we can get this stuff wrong. Leg, leg, hypotenuse. Square the two legs, add them together, we got 34.3125. Take 6, square it, we get 36. While these numbers are close to each other, they have to be exactly the same number, okay, for our triangle to be a right triangle. So, because they're different, right, we do not have a right triangle. And then they give us ones like this.
Oh, yes.
Okay.
I like these.
So what looks different about these three numbers here? You guessed it. 2 of my 3 numbers are in disguise, right? They're in these radicals. So I probably need to get all of them looking about the same so I can at least figure out A, B, and C, right? Who is who in terms of this? So the square root of 205. Again, I don't need to be totally accurate. Guys, this is about 14.3. I need to be a writing device. This is roughly 14.3. Okay, the square root of 105 is about 10.2. Okay, so now do I know which one of these side lengths is the hypotenuse? I do. Biggest number. So leg squared plus leg squared equals hypotenuse squared. Right? So is this going to be a right triangle? A squared plus B squared equals C squared. Plug in your numbers. So 10 is a leg. This square root of 105, guys. Square root of 105 squared. Okay, look, I just take the square root of 105. We're going to square it. And then I'm going to do the same thing with 205 squared. Okay? All right. So let's see what numbers these all turn into. You guys ready? 10 squared turns into 10. No, 100. That was bad.
I was going to have to correct you, but
Yeah.
you caught yourself.
The square root of 105 squared. Again, if you're not sure what number that is, guys, you literally can take this number, 105. Why did my parenthesis go that way? 105. Square it, and yep, we get 105. Okay, this always happens, people. This right here is going to be 205. Okay, 100 plus 105. I'm not good with numbers, but that's 205. Okay, did we get the same number? Are those two numbers equal to each other? Is this a true math sentence? Whatever you want to say. The answer is still yes, it is. Is this a right triangle? You betcha. Okay? Great. Example 3.
Another one.
See if we can't get some bad numbers here.
Ray drew the
Ray.
isosceles triangle LMN and the segment LP. How can Ray tell whether the segment drawn is the height of the triangle?
Okay? How can you tell? We don't really know. Okay? Let's see what he's going to do. So, boom, here we go. A squared, B squared, C squared, that hasn't changed, right? You've got to plug in your numbers. So 1.3 and 3.5, those are your two legs of the triangle. Got something stuck in my eye, that's great. 3.7 is our hypotenuse, okay? Process is still the same. Square the two legs, add them together. Ray gets 13.94. takes the hypotenuse, which was 3.7, squares it, gets 13.69. Again, compare these two numbers. Are they equal to each other? Nope. Once again, close, but that doesn't matter. They have to be exactly the same for this to be a right triangle. Okay, so it is not a right triangle. Same thing here. We got a nice trapezoid here. They've shaded in a triangle over here. Want to know, is it a right triangle? Okay, well, good news. Don't have to do much here. I already know what the legs and the hypotenuse are. So we can write these in. Again, if we're going to use the formula, let's write it out. And let's plug in what numbers go where. So 15 squared plus 17 squared is going to equal 514 squared. You guys good so far? I think so. All right, so 15 squared, 225. 17 squared, 289. 514. When I take the square root of that and square it, it turns into 514. Okay? We add our two legs together. Now this gives me, wait for it, 514. All right. Is 514 equal to 514? You better believe it is. So is this a right triangle? Absolutely. Absolutely. So guys, hey, this is what today is, right? Shouldn't be that tough of a day for us. So tune into the key concepts, and we're going to get rolling through that, and you should enjoy it. See you there.